Hello friends, welcome back. In this tutorial, we will study about heap sort algorithm. Right? Suppose an array A of elements is given to us and we have to sort the elements of this array A in increasing order by heap sort algorithm. So what will we do? First of all, we will build a max heap by the elements of array A. Right? Now, we know that the largest element in max heap is stored at root. So, root should be the last element of sorted array A, right? We know that heaps are implemented by arrays in memory, right? This max heap is stored in memory as an array A, right? So we will exchange the root of max heap with the last node of the heap, right? Now we will decrease the size of max heap by 1, right? We will decrease the size of max heap by 1 so that last element is not included in max heap, right? This last element is not included in max heap. Last element of array A will remain there, but it will not be included in max heap, right? Now, root of max heap may violate max heap property. So we will apply max heapify algorithm on root so we will apply max heapify algorithm on root so that once again all nodes of this heap satisfy max heap property and the largest element gets in root. After applying max heapify algorithm on root, right? What will happen? We will get all nodes of this heap satisfying max heap property, right? So the largest element of this heap will be stored in root, right? Now the second largest element of array A is stored at the root of this heap, right? So we will again exchange the root of heap with the last element of heap so that second largest element of array A occupies second last position in array A, right? Then we will decrease the size of max heap by 1, right? And apply max heapify algorithm on root, right? We will repeat this procedure until all elements except root are removed from max heap. Then we will get all elements of array sorted in increasing order. It will be more clear after this example. Suppose an array A is given to us, right? And we have to sort the elements of this array in increasing order, right? So first of all, what will we do? We will build a max heap by the elements of array A. Now, suppose after building max heap of the elements of array A, we have got this max heap, right? This is the max heap which we have built from the elements of array A, right? This is the max heap, right? And it is stored in array A in memory, right? Now, see here, the largest element in max heap is stored at root, right? So the root element, right? It should be the last element of array, right? It should be the last element of sorted array, right? We know that heaps are implemented by arrays in memory, right? This max heap is stored in memory as an array A, right? We will exchange the root of this max heap with the last node of heap, right? We will exchange the root of max heap with the last node of the heap. Now, the element 16 is stored as the last element of array A, right? Now, we will decrease the size of heap by 1, right? Now this element 16 is not included in max heap, right? But element 16 is stored in array, right? Now the element 2 is at root. It violates max heap property. So we will apply max heapify algorithm at root to shift it at right place in heap so that all nodes of this heap satisfy max heap property, right? So what the max heapify algorithm does, value of this node on which we have applied max heapify algorithm, right? The value of this node, value of its left child and the value of its right child, these three values are compared to find the largest value among them, right? Value of its left child is largest, right? So we will exchange the root with its left child, right? Now the left child of root has got a new value, that is 2, right? And it violates max heap property. Its value is lesser than the value of its children, right? Now value of its left child is largest among the value of this node, the value of its right child and the value of its left child, right? This value is the largest. So we will exchange this node with its left child, right? So after exchanging this node with its left child, we will get this tree, right? After exchanging this node with its left child, we will get this heap, right? Now this node has occupied the position of its left child, right? Now here it does not violate max heap property, right? Now all the nodes of this max heap satisfy max heap property. Now the largest element of max heap is at root, right? The largest element of max heap is at root. Now it is the second largest element of array A, right? In sorted array, the element at root, it should be at second last position in array A, right? In sorted array, it should be the second last element, right? Now we will exchange root with the last element of a heap. So we will exchange element 14 with the element 3, right? In max heap, right? We will exchange element 14 with the element 3 in max heap, right? Now after this, after exchanging it, what will happen? This element 14 will occupy second last position in array A. It will occupy second last position in array A, right? So what will we do? Now we will decrease the size of max heap by 1, right? Now element 14. Now when we decrease the size of max heap by 1, the element 14 is not included in heap, but element 14 is stored in array A, right? Like element 16, right? Now we will apply max heapify algorithm on root, right? Element 3 is at root, right? Now the largest value among root, left child of root and right child of root, right, is of right child of root, right? So what will we do? We will exchange root with its right child, right? We will exchange root with its right child, right? Now when we exchange root with its right child, right, then what will happen? This element 10 will become root and this element 3 will become right child of the root. So we will get this tree, right? Now, the right child of root has got a new value, right? We will apply max simplify algorithm on it, right? When we apply max simplify algorithm on it, its value is compared with its left child and its right child. Now this node does not have any right child, it has only left child, and value of its left child is greater than it. So we will exchange this node with its left child, right? So when we exchange this node with its left child, right? So this node will get this position and this node will get this position. So we will get this tree, right? We will get this tree, right? Now the left child of this node, it means this node has got a new value, but it does not violate any maxi property, right? So maxi simplify algorithm will terminate here, right? Now see, after this again, all the nodes of this max heap satisfy max heap property. Largest element of max heap is at root, right? Now what will we do? We will exchange root with the last element of max heap, right? Now we will exchange the root with the last element of max heap and decrease the size of max heap by 1, right? So when we exchange root with the last element of max heap, right, what will happen? This element 3 will become root of max heap, right? So what we have done, we have exchanged root with this element 3, last node of max heap. So 3 has become root of max heap. After this we have decreased the size of max heap by 1, right? Now this element 10 is not included in max heap, but it is present in this array A, right? Now after this we will apply max simplify algorithm on root, right? Now after applying max simplify algorithm on root, what will happen? See, the largest value among root, its left child and its right child, is of the right child of root. So root is exchanged with its right child, right? So this element 9 will become root and this element 3 will become right child of root, right? So we will get this tree, right? Now no node of this max heap violates max heap property, right? So now the largest element is at root, right? The largest element of max heap is at root, right? Again we will exchange the last node of heap with the root, right? We will exchange root with the last node of this max heap, right? This is the last node of this max heap, right? When we exchange, what will happen? This node will get the position of this node, right? Root node will get the position of this node, right? So this element 9 will come here in array, right? And this element 7 will become root, right? After this, what will we do? We will decrease the size of max heap by 1, right? Now we will decrease the size of max heap by 1, right? Now this element 9 is not included in max heap, but it is present in array A, right? It will remain in array A, but it is not included in max heap, right? Now the element 9 has occupied 4th last position in array A because it is the 4th largest element of array A, right? Now we will apply max heapify algorithm on root, right? Now see, here the value at root is 7, right? Its left child is 8 and its right child is 3. So the largest value among these three nodes, root node, its left child and its right child, is of left child of root. So we will exchange root with its left child, right? After exchanging root with the left child, with its left child, we will get this tree, right? Now, left child of root has got a new value, that is 7, but it does not violate any max heap property, right? If we compare its value with its left child and its right child, it does not have any right child, right? We will find that this node does not violate max heap property, right? So max heapify algorithm will terminate here, right? Now again, all nodes of this max heap satisfy max heap property, right? Now the largest element of a max heap is in root, right? So again we will exchange root with the last element of max heap, so that element 8 will get the position in array A where it should be in sorted array, right? So we will exchange root with the last element of max heap. This is the last element. This element 2 is the last element of max heap, right? So when we will exchange, 8 will come here and this element 2 will become root. So we will get this tree, right? After this we will decrease the size of max heap by 1. Now this element 8 is not included in max heap, right? Now this element 8 is not included in max heap, right? But it will remain in array A, right? After this we will apply max heapify algorithm on root, right? Now the value at root is 2, its left child is 7 and its right child is 3. The largest value among root, left child of root and right child of root is of left child of root. So we will exchange root with its left child, right? So after this, 7 will become the root, right? And 2 will become the left child of root. Now the left child of root has got a new value, that is 2, right? But it does not violate max heap property, right? Left child of root does not violate max heap property. So max heapify algorithm will terminate here, right? Now the largest value of max heap is at root. So what will we do? We will exchange root with the last element of max heap, so that element 7 will get the position in array A which it should have in sorted array A, right? So we will exchange root, that is element 7, with the last element of max heap, right? Last element of max heap is 3. So we will exchange 7 with 3, right? Now after this we will decrease the size of max heap by 1. Now 7, this element 7 is not included in max heap, but it is present in array A, right? Now the element 3 has become root. We will apply max heapify algorithm on root, right? We will apply max heapify algorithm on root. So this root has only one child, right? And it is its left child, right? Now its left child is smaller than it, right? This left child of root is smaller than the root, right? So this root, this node does not violate any max heap property, right? So max heapify algorithm will terminate here, right? Now the largest element of max heap is at root. So we will exchange root with the last element of max heap. This element 2 is the last element of max heap, right? We will exchange root with the last element of max heap. We will exchange 3 with 2, right? Now after this we will decrease the size of max heap by 1, right? After exchanging root with its left child, right? then 2 will become the root, and we have decreased the size of max heap by 1, right? Now the element, as we have decreased the size of max heap by 1, the last node will be removed from the max heap, right? This node 3 is not included in max heap, right? Now the max heap has only one node, right? Now we will apply max heapify algorithm on the root of max heap, right? So it means we will apply max heapify algorithm on this node. Now since there is only one node in this max heap, that is this node, so it does not violate any max heap property. So max heapify algorithm will terminate here, right? Now since only one node is left in this max heap, so heap sort algorithm will stop there, right? Now see, all elements of array are arranged in increasing order, right? Now this array is sorted in increasing order. In this way we can sort the elements of an array by using heap sort algorithm.